Right, here are solutions to quiz 3 for Math 243. Asked 5 questions. Yeah. Asked 5 questions about this data right here. First question is determine which variable is the explanatory variable and which is the response variable. Explanatory variable is kind of the cause, response is the effect. So what I will do here is be kind of lazy and I will say explanatory variable is snowfall. And response variable is the number of accidents. And the reason why is because you can imagine snowfall causing accidents, but I don't think you can imagine accidents causing snowfall. So I'll say because snowfall causes accidents. Alright, calculate the least squared regression line and interpret the slope and the intercept. So to do this, you want to put your data into a calculator, into your TI, and then you go stat, calc, and then linear regression. I think it's linreg ax plus b in your calculator, I believe. And so I will do that. I'll pause this and get the answers. Is linreg ax plus b. And what you get when you do that is it will tell you something like y equals ax plus b. Really should have a y hat up there. A is equal to 4.3 and b is equal to 2.8. So your linear regression model is y hat equals 4.3x plus 2.8. And we can interpret both our slope and our intercept here. The intercept is saying if your explanatory variable were 0, if there was no snowfall, we'd expect 2.8 accidents. If no snowfall, we'd expect 2.8 accidents. Alright, and then this slope here is saying that for every increase in the explanatory variable by 1, that is for every extra inch in snow, we expect 4.3 more accidents. We're running out of room here. More accidents. Good enough. Alright, part C says create a scatter plot of the data and graph that least squared regression line. Alright, we can do that. A little bit tedious, but it's doable. We got to make sure we put our explanatory variable down here and our response variable up here. So we want snowfall down here and accidents over here. And it looked like snowfall goes from 0 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And accidents go up to what, 45. So 10, 20, 30, 40, 50. Good enough. Now it's good enough. And then what you do is you plot each of these points. So our first point is when x equals 3, y equals 18. So here's 3, 18, I don't know, somewhere in here. Next one is when x equals 0, y equals 5. So here's 0, here's 5. Then you continue in that fashion. 3 and 20, 1, 2, 3, 20, 2 and 9, 1, 2, 9, 5 and 21. Probably should pause this video and do this on my own time. But we've gone this far. 3 and 15, somewhere over there. 2 and 6, somewhere down there. 8 and 39, so way out here, and way the hell up here. 10 and 45, there's 10, 45-ish, and 4 and 22. 4, 22. So something more or less like that. And then we can graph our regression line. our regression line, I'll do it in a different color. We have a y-intercept of 2.8, and then we go up 4.3 every time we go over 1. So if we went over 10, we'd go up 43. And 43 plus 2.8 is 45.8. That is, at 10, we should end up at like 46, which is right about on here. And if we try to connect those with the straight line, easier said than done on a computer. Not too bad, that's pretty straight. We get our least squared regression line. If you want, I can even label that little point right there is 2.8. You don't have to do that. Okay, so we have a scatter plot, we have a least regression line, we're good to go. Calculate the residual of the first observation. All right, residual is always observed minus expected. Way to write that is it's y minus y hat. So we have to calculate y hat. Well, let's see, we can calculate the expected amount. It's 4.3 times whatever the x value is, 3 in this case, and then add 2.8. Let's see, I could probably do this in my head. 4 times 3 is 12.9 plus 2.8, which is what, 15.7? All right, so we have that our expected was 15.7, however, our observed was 18. So we get 18 minus 15.7 is 2.3. So what that means is that this observation, 318, 1, 2, 3, this guy I think, is 2.3 higher than we expected. It's a little bit above this line. Although it doesn't ask you to interpret it, so we're good with just putting my residuals 2.3 and moving on. And then determine and interpret the coefficient of determination. I was friendly enough, I told you that that's r squared. You can get that straight out of your calculator, and that the same thing that gives you all this information. You get r squared is equal to 0.95, 0.947 maybe. And so what that means, so 94.7% of the variance in our response variable in accidents is explained by our explanatory variable, which is snowfall. And that is the end of this, what is this, a quiz? That's the end of this quiz video.